Thanks for joining me for MTI's Whiteboard Wednesdays. I'm Dan Adams. Today we're talking about low force friction welding for dissimilar metals. Today we're going to talk about low force friction welding of dissimilar metals. And if you've seen our previous episodes, you know that traditional friction welding is a great way to join dissimilar metals. And just about any metal that can be formed can be forged using traditional friction welding. So why would we move to low force friction welding? Well, the reason is you get all the benefits that we have from a value perspective with low force friction welding. We can make welds with low upset. We can do post-weld heat treatment. We get faster cycle times. But we now also have the ability to balance the input heat or imbalance the input heat. So in traditional friction welding, if I want to weld a bar to bar, I have to rotate one component and I have to apply a forge force against it. That's the only levers I have to pull in order to balance the heat. And if I have two components that are drastically different in characteristics, I have to balance that heat towards the component which is more difficult to weld. This makes it really challenging to make dissimilar welds in traditional friction welding. Now, we've found ways to do it, but it's challenging nonetheless. In low force friction welding, we can imbalance the heat so that we can focus it on the component that is more difficult to weld. Therefore, we have more ability, more leverage, more levers to pull to make a low force weld while still getting all the other benefits. So if we start looking at some of the applications that we can do, here's an example of aluminum tube to a steel tube, and this simulates, for example, a drive shaft that we might do for an automobile. We can also do solid components. Here's, again, it's an aluminum to steel component, but this is solid. We did this with a round interface. We actually did it with linear reciprocating motion, but you can see how little flash was generated, how little upset we got, which is drastically different than what we were doing if we used traditional friction welding. In a previous episode, we talked about the micro welder that's EWI. Now that application was an aluminum stud to an aluminum plate, but it doesn't have to be. It could be copper to aluminum. It could be an EV solution, something in the battery box connecting to the bus bar. We can put multiple studs onto a plate as well. And the benefit of low force here is because the forge force is so low and we can imbalance the heat, we can make these welds without any backside deformation to a very thin plate. So that is a new application or a new geometry that can't be done with traditional friction welding. And then obviously we can do the traditional complex geometry. Here's an example of an aluminum to steel weld that was done with a very complex component using linear friction welding. So again, we can do all the same dissimilar combinations with low force friction welding. We have a few more levers to pull in order to improve joint quality, but we get tremendous solid state joints with all the benefits of low force friction welding. Thank you for joining us for this episode of MTI's Whiteboard Wednesdays. For more information on this topic or other friction welding solutions, please visit our website at mtiwelding.com.